This is Jenny Kunkel, and in this video we are going to take a look at inner joins with Oracle. This is very similar to our SQL Server. Our joins work essentially the same way, but we'll just kind of walk through a scenario so we see how we can create the entity relationship diagram that's going to give us a picture of how the tables are interconnected. We can look at the properties between the two table links, the relationship, and then also go through and actually select something that is using multiple tables within Oracle. So let's start by going to the File menu, and we're going to use the Data Modeler. This is going to be using the Import option with the Data Dictionary. Now, if we look at our tables over here, we have our customer, our inventory, our order items, orders, products, shipments, and stores. When we look at an order, it's going to have relationships to everything but the inventory. So when we go through our selection of tables, we're going to get everything but the inventory to get a complete picture of our order. Let's go ahead and select the CO for our connection, hit Next, hit our CO for the schema, hit Next, and then I can go through and select everything, which I'm going to do, and then unselect the inventory. So I have everything but inventory I want to include in my diagram. I can hit Next and Finish. This is going to bring in my entity relationship diagram. So this is going to, and I'm just going to move this around just a little bit so I can see these things a little clearer. With our diagram, our order is essentially going to be our lead table because our order starts with our order table and it has relationships to the customer. It also has relationship to the store. These are going to be foreign key associations. We can see based off of the store ID and the customer ID that there is an F next to it. That means that those are foreign key relationships. We can see that the order ID is the primary key. We also have in our customers, the customer ID is a primary key. We can see that we have a unique key on our email address. So that's something that we haven't seen in any of the diagrams in SQL Server. Now, with our orders, we're first going to join it to our customers. And if we want to see what this is going to be joined on, if it's not intuitive, we can always look at the properties. This is going to give us the correct answer. So we have the customer ID in the orders table and the customer ID in the customer table. That's going to be our first join condition. And let's go to a query window so that we can add that. And we will go ahead and add the order ID, the customer ID, order status, store ID, and then also pick up the customer ID and the email address. So let's go ahead and do that. So we have select, and just to start out like we did in SQL Server, we're going to go ahead and order ID, customer ID, order status, store ID, full name, and then email address. So those are all of the fields from those two tables. We then want to go ahead and specify our first table. This is going to be orders, and we are going to inner join orders with customers. And our join condition is going to be on orders.customer ID equal to our customers.customer ID. I also want to order everything by the order ID. Now, if I run my query, it should execute, but guess what? We have something happening here where it's indicating that we have a column ambiguously specified. Now, in SQL Server, it showed us that in the IDE. We saw that there was a conflict before we ran the query. Here we don't necessarily see the conflicts until we actually run the query and get the ambiguous column specified. That means that I need to specify which table I'm getting this column from, and that's going to be the orders.customer customer ID. Once I do that, I can rerun it and then it works. So that's kind of the first step. Now, we also talked about the fact that we can alias our tables, and if we try to alias them with an as O, notice we have a little bit of an issue here. We have this pink squiggly that is not resolving. If we remove the as, it's a little happier. So unfortunately with Oracle, we can't use that optional as. That has to be omitted. And we are going to add our C here. We would go through and change our references to match. Then I could run this query. It should return the same information as what we saw previously. Now let's go ahead and let's alias all of our fields to the appropriate table. We talked about that is a best practice in case somebody would happen to do something to add a column while our code's in production. That would cause our program to fail, and it's much safer if we're actually indicating which table we're getting the field from, and if there is some type of a conflict, it wouldn't matter because we have it specifically telling it to get it from a certain table, and everything would be fine. So this is going to be O.OrderID, O.OrderStatus, O.Store, C.FullName, and C.email address. We're going to also order this by our O.OrderID. Now everything is referenced as far as tables go. We can go ahead and go back to our relationship diagram, and this time we want to get the store. We have a relationship between the two tables. If we look at the properties, it's the store ID to the store ID. Let's cancel out of here, and maybe we just want to get the store name. So let's go ahead, go back to our worksheet, add in our store name. We'll add the prefix shortly. We're going to go ahead and do an inner join of our store. We'll make this S, and this is going to be on O.StoreID is equal to S.StoreID. And we'll come up here and change this to an S.store name. If we run this, we should pick up that store name. Everything seems to be working fine. Let's go back. Now we've satisfied our foreign key relationships here. We want to move on, and we want to include our order items. If we look at our diagram here, we have a P and an F next to our order ID. So that indicates that it is part of the primary key for this table. And if we come down here, we can see that the order item's primary key is the order ID and the line item ID. It is also part of a foreign key. We also have on our product ID that it is a U, meaning that it is a unique index on that field, combined with our order ID to ensure that we only have one product specified per order. We can't put more than one product with the same product ID on one order. So that's going to be something that we take into account when we create our tables. Now, this is going to be something that we want to select the line item ID, the product ID, the unit price, the quantity, and heck, we'll throw in the shipment ID as well. So let's go back and let's add in those fields. We'll put the table alias on after we add the join condition. This is going to be line item ID followed by product ID, unit price, quantity, and then the shipment ID. Our join statement is going to be inner join order items. We'll call this OI on O.OrderID equal to OI.OrderID. We're going to come up and add that OI to our line item ID the product ID, unit price, quantity, and shipment. We probably also want to order all of the information being returned not only by the order ID, but also by the order's line item ID. Let's go ahead and add that oi.line item ID. Then if we go ahead and select our query and run it, we can see that we have a couple that don't have a shipment ID. Isn't that interesting? Means probably we're going to skip those records when we do a join to the shipment table. So notice that they were canceled. They have an order status of canceled right now. If we would go down, we'll take a look at this. We'll keep in mind how many rows we have selected, and you'll notice that it's only picking like 50 rows at a time. This is kind of one of SQL developer things. It buffers about 50 rows at a time, and you have to keep scrolling to get the whole entire count. So we have 3914. So that's a number we should kind of remember, is 3914. So when we get done and we've joined in our shipment information, we should see if we have like at least how many rows in this have a null, and we should just kind of look at that. So let's just go ahead and put in a where statement just to look at how many are null for the shipment ID, because that might be a little interesting. oi.shipment ID is null. Run this. We have quite a few that are null. We have 1238 that are null, so that's something to keep in mind. Okay, so I'm going to go ahead and remove that where statement. We've just seen how we can add where clauses to our queries. We could also put them on the inner join, but again, that's not traditional to do that way. Now we have our order items. Let's go back. We have our products. Let's pick up our product name. We're not going to necessarily worry about anything else. We know by looking at this relationship that it is ordering on the product ID between the two tables. So I'm going to come up here, put my product name. I'll add the table alias after I add the join. This is going to be on oi.productID equal p.productID. Make this p dot. For our product name, I can run my query. I should be picking up my product name now, which we see there. And let's go back and let's pick up our last thing, which is going to be our shipment status. When we join this, we should see that possibly we're going to lose some rows because of that shipment ID being null. So let's go back, and we have our shipment ID. We can look at this relationship, and we can see that it is shipment ID to shipment ID, just as we expected. So I'm going to go ahead and add that shipment status. I'll add the table alias later. We're going to do our inner join on shipments. Call this SH because we already have an S for stores. And this is going to be on oi.shipmentID equal to sh.shipmentID. We'll add our sh prefix here, and let's go ahead and run this query. And as we scroll across, let's scroll down here. Let's take a peek at how many rows we might have. And one of the things that we had previously was we had 3,914 rows being returned before we joined our shipment table. We kind of did that is null check to see how many rows were returned that had a shipment ID of null, which was 1238. Now when we look at 3914 minus 1238, we have 2676, and by golly, guess how many rows were returned? We've gone to the bottom of our result set. We have no more rows to return, and we have 2676 6 that are returned. We eliminated quite a few records just by the fact that there was a null shipment ID. All right, so that is our join. We can see that if I wanted to go through and maybe find all of the shipment status records that have a status of created, I can add that to my where statement. So this is going to be the sh.shipment status equal created. I could run this query and it's going to give me 2 records back. So I can add those qualifiers as well. The last thing that we want to do before we stop in this video is we want to try using the old style way, not the modern ANSI standard way, but the old style way of doing queries. So we're going to go ahead and take our list of columns. We're going to move it down below. Then we're going to go ahead and add our where statement and our order by, leaving a little bit of space for our tables. And then we're going to start with the from here. So we have from orders O. We're going to go ahead and add to that, tabbing in the customer C, the stores S, the order items OI, the products P, or shipments SH. Then we have quite a few additional things that we need to add to our where clause. We have our customer ID qualifier, our store qualifier, or order ID qualifier, our product qualifier, and then our shipment qualifier. If we run this query, we should have the same results being returned. We've pretty much gone through the same types of things that we did in the SQL Server. We've done that in Oracle now.